I don't think this integral is very easy. And before I'm doing this integral, I want to introduce some property is well in integrations. The first property is that well, let me use this pen. I want prove a to b from a to b f of x dx is equal to from a to b f of a plus b minus x dx. Okay, to prove this is rather easy because I let x be a plus b minus t. Okay, so my integral from from a to b, this will be equal to f of a plus b minus t, right? And dx will be negative dt. When x equals to a, t is b. When x equal to b, t is equal to a. Now then, well, xt just dummy variable, so this one is equal to from a to b, f of a plus b minus x dx. Okay, so that's approved. Prove the first property. Now prove the second property. The second property is this. If f of a plus b minus x is equal to f of x, then f of x dx from a to b will be equal to a plus b over 2 from a to b f of x dx. What? That is the property. When f of x is equal to this, then f of x dx will be equal to this half a plus b times the integral of f of x dx. Now let me prove this. Okay, prove this property. Well, okay, how do we prove this one? Okay, now let me start with this. Okay, proof the integral a to b x f of x dx is equal to, according to the above property, which is equal to from a to b a plus b minus x, right? It's for this one times f of a plus b minus x dx. Right? Yeah. So this one is equal to a to b, then a plus b times this one. This one is equal to f of x, right? This one times this one is equal to this times this, right? Because this one is equal to this. This one's equal to f of x as a given, right? Then minus the integral from a to b x times this one. This one is this as a given, right? And this is my given integral, which is this is equal to this one. This is I, right? So this one's a to b x f of a dx is equal to half of that, half of a plus b, the integral from a f of x dx. Wow. So I proved this property. No? I proved that this integral is equal to this. If this equal to that, if f of x equal to f of a plus b minus x. Okay, so I proved it. Now, what a situation is when this one equal to that one? When f of a plus b minus x is equal to f of x, what does this function mean? Okay, that means is, look, if you use a graph, it's much easier. This is x, right? This is f of x. Okay, this point is a plus b minus x, the same height. Okay, this is f of a plus b minus x. They are same height. Okay, they are equal. They are equal. Therefore, they are symmetrical with respect to the midpoint, right? The function is symmetrical with respect to the midpoint. What is the midpoint? This plus this by 2. So this one, this. So that means when the function is symmetrical with respect to x equal to half a plus b, then this property will be true. Okay. Now we can do let me find the paper. Okay, let me do this one in the beginning, right? Do this one by using the property here. Well, I hope my explanation is clear. Now, let me do this integral from pi to 4 pi. X sine cube of x cosine 4th x dx. Okay, that is the integral in the beginning I want to do after introducing these two properties. Okay, all right. Now, f of x is equal to cosine. Then my question is this f of x satisfying this property? If this function satisfying this property, then I can use this result. Instead of integrating this one, I'm integrating this. That's the whole story, okay? Now let me check. Okay, let me check with f of x. This is a, this is b, right? It's is a 5 pi minus x. A plus b is 5 pi. This one is equal to 5 pi minus x times cosine fourth 5 pi minus x. Okay, that is good. 5 pi is a 4 pi plus pi, right? So it's equal to 3 pi minus x. Multiplied by cosine, no, let me write again. This one equal to sine cube pi minus x. That's true because the 5 pi means 4 pi plus pi. 4 pi is just two, no, two periods of for sine, right? So this one is this is a cosine fourth pi minus x. Yeah. So this one equal to sine pi minus x, the same as sine, right? So this is true. This one is equal to negative, right? Cosine x 4 pi. Yeah. That is equal to positive. Positive. Therefore, same equal to 4. So they are equal. So this one is equal to that. Then my integral I, well, I is equal to pi or x sine cosine fourth x dx. Now then, according to my, if this one is true, then my integral can be done with like this. Okay. So this one could be done as a 5 pi over 2 integral from pi to 4 pi sine cosine x dx. Right? In other words, we can drop this x out by multiplying 5 pi over 2. See, this is a nice result. I'm using using the property. So this one equal to 5 pi over 2 integral from pi to 4 pi sine cube is sine square. This is sine square, right? This is sine square. The other sine, I change it to d cosine. D cosine is a negative sine dx. So I put a negative outside. The negative outside. So this one equal to negative 5 pi over 2, right? Integral pi to the 4 pi cosine fourth x minus cosine, right? 6x d cosine. Wow, that is very easy. This is a 5 pi over 2. This integral is 1 over 5, right? Cosine 5 x minus 1 over 7 cosine 7x from pi to 4 pi So this was negative 5 pi over 2, 105. This is equal to 1 for 4 minus 107th minus cosine pi is negative 1. So negative, right? This will be positive. Yeah, this is negative 5 pi over 2. This is minus over 7. Huh? This is negative 37. 4 over 37. It's 7 or 2 pi. Wow, that is a very result for this integral, which is not easy. But using the properties, using this property, this equal to that, this is equal to this. Using this property, my integral could be simplified by dropping this x out. And this is very nice, very, very good method now to apply for this particular integral. Thank you.